Welcome to Study Loop.
Alright, to construct the table representing the sampling distribution of the sample mean, we need to calculate the mean of each sample of size 2 that's randomly selected with replacement. This would mean you could get a 33 and a 33, which has a mean of 33. You could draw a 33 and a 32, which would have a mean of 32 and a half. You could draw a 33 and a 25, which would have a mean of 29. You could draw a 33 and a 13, which would have a mean of 46 over 2, it would be a mean of 23. We're just adding them and dividing by 2. Sample 5 could be a 32 and a 33, which has a mean of 32 and a half. Then you could draw a 32 and a 32, which has a mean of 32. And you could draw a 32 and a 25, which would have a mean of 57 divided by 28.5. You could have a mean of 32 and 13, which is a mean of 22.5. You could draw a 25 and a 33, which would be a mean of 29. You could draw a 25 and a 32, which would have a mean of 28.5. You could draw a 25 and a 25, which would be a mean of 25. You could draw a 25 and a 13, which is 38, which would be a mean of 19. You could draw now a 13 and then a 33, which would have a mean of 23. You could draw a 13 and a 32, which would have a mean of 22 and a half. You could draw a 13 and a 25, which would have a mean of 19. And you can draw a 13 and a 13, which would have a mean of 13. So the probability of getting a 33 as the mean is just this one here, which would be 1 out of the 16. There's 1, 2, 32.5, so that's 2/16, but you could also write that as 1/8. A 32 can happen once. A 29 can happen 1, 2 times. So that would be 2 out of 16 or 1 out of 8. And a 28.5 can happen once, twice. A 25 can happen once. A 23 once, twice. A 22.5 twice. A 19 twice. And a 13 just once out of the 16. So that would be your probabilities.